Okay, can we start? Hi, I'm Dębski. I'm really happy to be here with you today, especially that I was called at 11th hour just 2 days ago that I can join, and I'm really happy because of that. Yeah, thank you. I'm quite sure that there was a lot of things said today about agents, about AI, etc. I'm a bit more optimistic about AI. I'm a bit more on the hype than my previous colleague. But let's talk about this. So I was here last time 6 years ago, and I picked the picture because I have less gray hair from since then. More gray hair since then. So I worked as an architect. I worked as an engineer. I work whatever needed. So right now I jump on the wagon about the agents, and I wanted to know something more about this. And to be honest, I work with the agents not from yesterday. If you are old enough, and if you are as old as I am, you might remember this. This is one of the biggest chat services in Poland. It used to be the biggest one. And there was one of the first agent that I worked with. It was called Guardian Angel. His main duty was to find whether someone used F words or maybe someone used some dirty words. And it was great to write this, but all the rules for the Guardian Angel was like 20,000 lines. And then I learned how many ways are to write F words, all the F words, and I even remember, and I've even learned that there are some numbers that are forbidden in Poland that you should not use in the public space. So that was amazing for me, and this agent was so stupid. This agent just had some regex rules. 20,000 or something like rules, and it picked all the single message and check whether it violates the rules or not. Fortunately, we don't need to do it anymore. So agenda. So let's discuss today about agents and why the multi-agent systems are much more fun, much more I would say sexy to build. We are on the JVM conference, so let's try to build something with LangGraph4j. So it's not the natural environment for the agents, but we can do it. Then we do some demo. We will look at the agents, and we will see how they work with each other, and even on the simple example, how it's easy to just destroy our application because we use agents. And then we discuss some pitfalls to avoid. So who is the agent? Agent, I like to think about the agents as a minion because it's very small thing. It look everywhere. They are everywhere. They look at they perceive all the environments all with their sensors. They read about, they read, they listen, they do everything. They gather and process the information, and they do something. Usually they do something stupid, like the minions, and usually they gather in the groups to make something less stupid, just like minions. So what it identifies the agent? So first of all, they can operate fully autonomously without our control. So we just tell them what to do, and well, basically that's what they should do. They react at our interactions. They should take some initiative. They should think about, and they should guess what to do to get their goals and to achieve their goals. And what is really important, good agents are just like minions. They are small, and they are they should achieve specific objectives, small goal, not think about the whole universe. So, what is the problem with the agents? I remember when we discussed years ago about microservices, we thought about building simple world. We wanted to simplify the processes, business processes that are in our organizations. It would be the best to have the linear process, or worst case scenario, graph processes, to make it easy to debug, to make it easy to write, to make it easy to understand. And what is most important, we wanted to have all the processes to be deterministic. We wanted to understand what's in our application. We wanted to dive deep and build these applications and be just like like the God for this application. But the world is slightly different. Let's think about some processes that we have. Let's think about the process when we need to do KYC. We want to know who we are talking to. Let's think about the Polish companies. So first of all, we thought, well, it's rather easy. So every company has identifier, so we can go to the government agency and get information about this company. Then get some other information from some other agencies, etc. But that's not the thing that actually KYC works. So first of all, you can be in different government agency. You can be small company, you can be big company, you can be the company that or umbrella company that gathers small companies. So we need to build branches. Sometimes if you want to know more about your customer, if you find some connected companies, you need to go back and find again information about the connected companies. Sometimes you go to another country, sometimes you go sometimes you make cycles because well, that's what good companies do. They make like cycles to avoid taxes. So that's really hard to write as a linear process. What's more, we have cycles, so it would be good to remember that we already look at the company and we gathered some related companies, not to do this for ages. And what's more important, we do it for Poland, then we go to Czechia. We think, okay, that's the same, they have identifiers. We build application, and then business comes and says, well, I have to tell you, they have two different types of identifiers, and they work interchangeably, and you need to guess whichever you should use. So we need to work in the world where we don't exactly know what we need to build. So what we can achieve with the multi-agent systems. So first of all, we want to have something that will control our flow of the application. So we want to have some kind of task orchestration. So we need to know which task goes after which. But what we also want, we want to have the flexible execution. So yeah, that's the order. But in some cases, we need to go back or go in the different directions. So we need to have some kind of orchestrator for this. We also need to have something which I personally hate, which is shared memory, because it reminds me a lot of the hated globals, because that's how sometimes people use it. So we need to share data between the agents, because our goal sometimes changes. So we started with looking for the specific company, and then we know that, well, it's not this company, this umbrella company. We need to find 10 different companies. So we need to provide this information to other agent, and we need to learn and adapt to this situation. So this memory for the agents are really important stuff. And with this uncertain, in this environment where we don't know everything, it is crucial to make possible to have possibility to look inside and to find whether what's going on, what the prompts are to our agents, what they actually, what results they have, and what bottlenecks, etc. So let's imagine that we have this minions, these are our agents. So we can think about them, and we can work with them in a supervised environment in the different patterns, different architectures. So first of all, the easy one, we have hierarchy, where we have a supervisor that guides whatever each agent should do. That's the very easy one. We can think about the army. You go there, you go there. But this is not the very nice agent environment. As we mentioned, they should be autonomous. So if we have this strong hierarchy, it is, well, not so autonomous for the small agents. We can go to the other side of this environment, and we can go with the total decentralized, the swarms, and you do whatever you want. You just pick the agents into the room and give them the problem and wait whatever they will bring you. That's also not so fun, because it might be hard to understand, and it might be hard to observe what's going on. And graphs, well, that's something in between. So it gives us some possibility to manage how this flow should go, but it also gives the agents way to say, okay, this is how this graph looks like, but I would like to go slightly different, and I want to rebuild this graph in a different way. I want to go back. This is something that we can go inside and stay there almost forever. So what we can use for this? With graph environment, it is hard to find the good tool because most of them are very, very young. The youngest here has 35 days since the initial release. The oldest one has almost 2 years, year and a half. They're going to be 2 years in September. So we don't have mature tools to use, but let's see what we can use. So first of all, there is AutoGen from Microsoft. It is a really nice tool to solve to design the agents in the way that they cooperate with each other and debating about the problems. So it is like a chat framework to solve the problems. And what is really nice, it is a good design to have the human in the loop. What means human in the loop? From time to time, agents just stops for some reason, or we want to stop them. And sometimes they want our clarification on, or we want to give them some hints how to interact. But what is worse with this? It doesn't have really good tools to monitor and to control the execution. As it is like the debiting, it is more like the swarm than typical than graph, what I mentioned before. True AI is also quite old because it was released 2 years ago. So someone thought that maybe it would be nice to build agents looking at the way that we are interacting with each other. So let's imagine that we have our company, our organization. We have the CTO, CFO, and other management. So whenever they need to make some decision, they just discuss. Every one of them has their responsibilities and their knowledge. So exactly like in Crew AI, we call these agents specifically. I would say, mimify the way that we interact in the teams, and that's how we can build this. It is also like the discussing framework between the agents. It is like role-based, because every agent has specific roles, as we call them. So we have coder, reviewer, or like in the companies. This is quite easy to understand, because, well, we just need to look at the world around us and implement just what we see. But it's much more strict than any other frameworks. So when our agent has their responsibilities, well, that's where they are stick to. So it's not so nice to play. Google Agent Development Kit, new kit on the block. It was released 1 month ago. It is great if you are stick to GCP. If you are on the Gemini, if you use GCP, it is your first choice. But if you want to use something simple, if you ever use something from Google, you probably know that where their tools are complex, they can do a lot of stuff, but learning curve are steep. So if you want to build something simple, well, that's not the framework that you should consider. And the one that I would like to encourage you to use, so it's LangGraph. It was a lot of LangChain today, so LangGraph, and we're gonna specifically discuss today LangGraph 4j, which is funny because someone took Python project and rewrite it to Java, and well, it's Python rewritten to Java. So it has all the drawbacks of Python and all the drawbacks of Java there. But still, you have LangChain there. And LangChain has a lot of connectors. It's huge ecosystem of the tools that you can use. You have tools like Langsmith and Langfuse that can give you the observability, just like you have in Honeycomb and other stuff in microservices. So it's really nice to look deep there. You can that's something that I'm really scared of. You can change the prompts on the live environment in this management tools. So it is really nice. It is flexible. You write every code, so you can do whatever you want. But well, it is not so simple. You need to look at this at the whole ecosystem, how it works, because it has some quirks and some strange stuff in there. But once you get into this, well, you can build some nice stuff. So let's look at the graph. So that's basically how any multi-agent system in LangGraph looks like. It has some important, well, actually 3 important components that are used. I cannot show. So this is nodes, edges that are between nodes, and state. As you see, state, well, actually states is everywhere. State is shared between every node, and it goes back and forth everywhere. So I should put it everywhere, but it would make the image so obfuse, and it would be hard to read. So the simple agent that we build looks something like maybe multi-agent. So first of all, we build the agent that want to understand what actually our user wants to achieve. So first of all, we have start. This is the special node that is entry point. It depends on the implementation. In Python, you can remove the start, you can put any node as an entry point. In langgraph4j, it depends on the version. Sometimes you can, sometimes you cannot. So here we have some basic implementation of multi-agent system. First of all, we get the information from the user, whatever they want. Then here we have this striped arrows, so it means that it is conditional edges. I will cover this later, but here we can see that if everything goes okay, we go to another agent. We pass all the information that we gathered from the entry and that we added by ourselves. We go to gather data. It can have some additional tool set, like go to web search, go to our database, use vector database that we have next to it, and it can go back and forth to the tools that we provide them. What is really important, the tools actually are grouped. All the tools that we provide to the agent are grouped in the node, and this is actually also the kind of agent, also the node. And when we decide that everything is okay, we have all the necessary data, we can go to the report. Again, we process all the data that goes from all the agents, and we go to the end node. What is really important, we can build this graph however we want. We can go back and forth to any node. We can have simultaneously edges that goes from our node that are normal ones and conditional ones that we need to check some data. So what is also important, state goes through all the graph, but it can be changed only in the nodes. And what is funny, nodes gets state as an input, but that's not what they put as an output, because it would be too simple. They put map of something that they want to change. And sometimes they put in the map other nodes that they want to direct the traffic. So as I mentioned before, we can build this graph up front and say, okay, that's how we want to do it. But then we can, in some place, in some agent, says, okay, and you can return to the system the next agent that you want to pass the data. It doesn't matter whether it is in the graph or not. You can pass whatever you want. So basically, nodes are just the functions, or in Java, it's encapsulated classes in the functions. As I mentioned, they take graph state as an input and return whatever should be updated, or maybe where should I pass the traffic after me. And again, we can complicate it a bit. We can encapsulate the whole graph in some node. So we can have nodes, graphs in the nodes, in the graphs, in the nodes, etc., etc. So we can have really, really big environment. Edges, as I mentioned, there are basically two types: the direct edge and the conditional one, and of course this hidden one, and the graph state. So graph state is a single source of truth for the workflow. And they are shared by all the nodes. And basically, in the easiest environment that we showed, that we saw here, all the nodes share exactly the same schema of the states. So it is easy for us, but sometimes it gives us some limitations. I will mention them later. So we have this agent, but sometimes when we have this agent system, we want to discuss with this. We want to build the chat, and the single graph is like the single response to our message in the chat. So how to make the agents remember whatever we are discussing about. So in the lang graph, this called the checkpoints. So we can write the memory at the end of the graph and read them in the next call. Whenever we group all the requests in the single thread, then we can use the same memory. So the state might go very, very big. So how to build this state? The simpler the better. So there is the pre-built states, which is called messages state. It has only one thing. It only have one key, messages, and in Java it is linked list beneath with the chat messages. By chat messages, I understand user messages, AI messages, and system messages. So all the messages are in this linked list, and this is the easiest way of the building lang graphs. And it also provides us nice feature. In the graph, we had this. We went from one node to two, and there were some code that were run in the parallel. But then we merge again in the report or in the end node. So this one. This message state has a nice feature. It is already pre-built reducer that merges all the states from the different branches that we have. So command pattern. This is the one that I mentioned before. Where should I go next? It is in Python and JavaScript. It is not in this Java, as far as I remember. And one more concept about this. Let's think about the single schema of the state that is shared for all the nodes in the graph. So sometimes it is nice, well, because it is easy to write, easy to understand. But let's think about two situations. One situation is that we don't want to expose both from the input to the input and to the output all the data and the schema that we are working on internally. So then we can use the different states just for those two nodes at the edges, at the borders. And second thing is, let's imagine that we have this graph which has node, which has subgraph, which has node, which has subgraph. It would be, well, undoable to share the state everywhere, and it might be also stupid because, well, we would share all the internal data that we don't need on the top. We would expose everywhere, and we would go with the really, really heavy state everywhere. Reducers, or so-called channels in the lang graph in Java. So those are the classes that decided how to merge the state when we have this merge of the edges. Multiple schema I mentioned. So supervised agents, because that's what's the really nice stuff in the multi-agent system. Let's imagine that we have a supervisor. We have supervisor as a node at the input, and they decide whether to go to the first agent or the second one. So here we have the agent at the same graph. They share all the schema the same. They know about each other. Even if we allow them, they can divert the traffic. So this is the simplest solution that we will look later. Sometimes we want to use agent or even the whole graph as a tool. So that's then we hide the complexity, and we hide the schema of the graph and the agent behind the API of the tools that we provide. So then it is like giving the order to some other agent. We don't want to discuss with them. We just want to get the result that we agree on. I don't care about the whatever they do. Just give me the result. And the last one, I would say the common used nodes as a subgraph, where we have the very big logic. We just divide them to the smaller one, and as we have here inside, we can use different schemas, different data to share, and we might not expose them. We might decide what part of the data we want to expose to the external world. Let's look at the code. So here I have some agents. Agents are written in the LangGraph4j, and it's also LangGraph4j heavily rely on the LangChain4j. So everywhere you can find the LangChain4j. So the simplest, let's go to the researcher agent. The simplest agent that we can have gets to the initialization language model. We can use whatever model we want. That's really nice with the LangChain environment, both in Java, in JavaScript, and in Python. All of the language models provide the same API, so we can use Llama, we can use OpenAI, we can use Gemini. Well, Gemini has some additional stuff, but Llama, OpenAI, or DeepSeek, and we can use the same model. So what we want to let's start with our well, every agent needs to provide the function apply. That's what actually is called from the outside world, and as I mentioned, it gets the state that we provide. It is the shared state in the whole environment. When I look at this, actually I did one thing. I used the messages state. So as I mentioned, the simplest state possible, and I share in the state every message that every agent write and adds to this stack. And I add one more thing for my supervisor agent, this key which is called next, which agent I should call after me. So my supervisor gets requests from the user and respond in the all the agents I should call next, and it stores it in the state. As you see, it is really nice because it is mapped beneath. So I can imagine that it was someone from the Python that wrote this, or someone that looked at the Python states and literally rewrite it to the Java. So what I do here, I take my state, and in the state I have messages. I take my last message, and here you can see very nice thing from the LangChain. It is both of the messages, both AI message and user message, implements chat message interface. And in chat message interface, there is text. There is text method, but it is deprecated. You cannot use single method to get text, even though it is just the text from the different sources. You need to have single text for the users and the text for the AI. It doesn't make more sense, but that's how it's written, and in LangChain, and it is from LangChain actually, and in Python it's the same. So there is no single consistency in the API. So we take the last message. We need to map it because, well, it is not the same, and we call our service with the message, and here we have the call to the our language model, and that's well what they respond. They respond with the result, which is again now it is AI message. So we get from the text AI message, and we add it to our state. And here, although I have my schema for the state, and I know exactly what keys are there, I need to return as a map, which actually it is checked against the schema. If it fits, if it not fit, it would be removed the keys. But well, I cannot use any object-oriented programming here. So here I have two simple agent. They are actually more or less the same. They have just different system message provided. So let's see at our workflow. So first of all, I need to build my my graph. When I build it, it is state graph. In the previous version, I can use it just for run. Now I have to compile it. It is the same as in Python. So I can, well, in the previous version, it was state graph builder, and I can use state graph that was built by this builder. Right now it is state graph, and when it is compiled, it is compiled graph. So it is moved from the Python. So I add my nodes. I add the classes that I want to have this node to support. I need to add. I don't need to add the special nodes like start and end because they are added automatically. But I need to add the edge. So when I add edge, it is like the direct edge. It is unconditional. It always goes from the start to supervisor. And from the supervisor, here we have this function that decides. It gets from the state because it has access to the state, and it looks at the next agent that should be called, and whether this is coder, it goes to coder, researcher goes to researcher, and if it's finished, it goes to the last node. And of course, I need to go back from the agents that was called to supervisor. And as you see here, it looks more or less like the infinite loop. And actually, it is infinite loop. So let's ask some simple question. So how to ask the simple question? I need to create message, and I need to pass this message as initial state to the graph. As you might guess, I pass it as a map because I pass it as a map, but it will be transferred as a state. And then I invoke and get the result. So let's check whether it works. Oh, that's the simple one. Oh. The debug. We will debug later. So I'm here. So how much is 1 plus 2? So I have my request. It is user message. And I have my response from the AI message. Well, it is free. Well, quite nice. So let's make something stranger. How many people live in Poznań and Kraków? And let's check. And it's infinite loop. It won't ever end. It just call the supervisor, look at the request, Okay, I need to check. I go to researcher that can gather some data, and researcher actually, we will look at this in the moment, respond, I don't know how to respond to this. Give me another question. And supervisor again, respond to this. It won't never stop. So let's look at the at this. So we are here in the supervisor. So let's take the last message from the. So let's look at the state. In the state we have one message right now. It is a message from the user. So let's go. We passed it to our LLM, and now we go to researcher agent. And what our researcher agent sees? Our researcher agent sees two messages. It says should be two messages. Oh no, there's one message because researcher doesn't add a message. Researcher only points requests from the user to specific agent. And our researcher responded, actually, and we are back in the supervisor. Respond. I apologize, but I don't have the data for Poznań and Kraków. I cannot respond. So what our stupid supervisor does? Well, try again. And again, and again, and again, and again. So it won't stop anywhere, anytime. So they can respond all the time the same response, but it won't stop. So actually, that's the one of the biggest problems with the agents and the multi-agent system. That is extremely easy to put into infinite loop. We can do either things that are in our mind quite reasonable, and we can put into infinite loop. So let's go back to the pitfalls. So first of all, the API is unstable. If you look at the Python library, it is even more unstable and inconsistent. You can look at the similar classes and they behave differently, and they get the different stuff. It is very, very young project. It is younger than Autogen. When we want to synchronize state, and we have these reducers or channels in LangGraph4j, we sometimes have some race condition here. So it is not exactly predictable how it would work. We can, well, just like in the real life, but sometimes it has some problems because when we have some, as I mentioned, the tool calls are also nodes. So whenever we call something, whenever LLM tells us call some code on your computer, it is this tool node, and it goes back. So it is another node in our graph execution. And unfortunately, LLMs and LangGraph here expects to have those nodes in the specific order and the messages in the specific order. So if we have the message from the AI and we don't have the response from the tool messages, or lack of the responses, or in the different order, strange things happen. Actually, it just collapses. Infinite loops. Again, on Python, it is by default 25 nodes, and then it just gives exception. So that was the thing that I showed you. We parsed the request, we passed to another agent. They said, I need more data, and we just pass it again and again and again. We even can have infinite loops when we have tool calls. So let's imagine that in this node, we want to gather all the offers for some search query. So what we do some get offers, we do some call to the REST API, and it depends of the religion. Either we respond with 404, or we respond with empty list, or whatever we respond. So what we do, we pass this empty list to the LLM. And the empty list sometimes serializes as an empty string, or is understood as an empty string. So what our LLM sometimes does, they ask again. Why? Because they didn't get response. They understand it as an error. So ask again and again and again. Easy way to make infinite loop with the with tool calls. As I mentioned, this message state and this agent state might become very, very big. Sometimes we want to put there some data for the conditional edge to decide whether to go this direction or that. And when we have this extremely big graph, it might become very, very big. And the last thing that I think about is it's hard. Sometimes it's hard to put it into our environment. We learned that our microservices are stateless. We know that they respond really quickly, and this is the real response times from the real system. So the P50 is like the 5 minutes, and it wasn't the error. It was just like the big graph. And actually, we had the problem with even when we triggered it with the events, because if you go with the GCP and the pops up, the default timeout for the event processing is 60 seconds. So you need to think it slightly different. You cannot go with the agents like I would remove my services, I would put agents, and everything would go smoothly. And that's all. Thank you. We have 2 minutes. I think that we have something like, okay. Artur, I think so. Maybe they migrated that LangGraph Python code base with LLM. Yes, I think so. I tried to do it yesterday with the code base I created in LangGraph4j. I tried to move it to the Python. It was crazy. Actually, if you want to play with this, be careful about the versions, be careful about the examples that you will find, because it seems like they were generated. It doesn't work. What is the biggest difference compared to having one agent? Is it like microservice? Okay, so that's I haven't mentioned. So if you have one agent, it looks at the world from the one perspective. Let's imagine that we have. I had this sample, but I removed it. Let's imagine that we have this guardian angel in the chat. Actually, we had some kind of this in the discussion between buyer and the seller in the marketplace, and we didn't want to pass the data, the personal data, like the email, phone number, and all the other stuff. But there were some exceptions. There were exceptions like if this email is from the courier company or some third party or something else, then we pass it. So we had two agents. One agent was focused on the finding extremely strange ways of writing phone numbers, like first 3 letters of each number. That's how they do on OLX. You can look at the ads. So that was the goal for this one agent. They had to find as many numbers as it was possible. And the second agent was like the guardian. Hold your horses. I think that this should pass, because I look at the bigger window, I look at the context, what they are talking about, and I think they are talking about and they are arranging the transport. So we can pass the number. So sometimes it is, well, for the simple task, simple agent. But if you write the bigger prompt with some ifs, and well, if there's some ifs and some conditionals in the prompt, it sounds like the multi-agent system, because you try to teach someone to do different stuff. Have you considered modeling agent as an actors? Yes, we did it. We did it Basically, LangGraph has a lot of LangChain has a lot of tools. That's why we did. As I mentioned with this Guardian agent before, so agent paradigm isn't new. It's with us from the 60s, I think, or 70s. So yes, Erlang and that is a great example of the agents. Will you share the sample codes? Yes, of course, because those are the samples that actually works. I looked at the examples at the libraries pages, and well, to find something in Kotlin, because I prefer Kotlin, it was impossible. To find something that works with Kotlin, it was also impossible, so I had to rewrite it. I will share it after. Well, do you use those graphs in practice? Those examples that I put, well, I worked with the marketplace company that one of the channel of the communication between buyer and seller, actually the single way of the communication was the chat. So there was even funny story. We put our agents in front of the sellers because every transaction began with the arranging addresses and confirming the availability of the stock, etc., etc. So we put the agents there, and well, it worked. And to be honest, we even had some transactions that has been made without human from the seller side because it was as good there. And right now, I dive deep in the Python and in the LangGraph. I'm really big fan of the LangGraph, and I see agents everywhere, to be honest. What do you think about other solutions like Nathan? I intentionally didn't put Nathan here because it's slightly different solution. It is rather automation workflow, and I think this is a great solution. If you have some team like if you have team that already automated something in PowerShell or some other stuff, and well, they are not pure developers, but they want to integrate Jira and Zendesk and your internal or your BigQuery, etc. Because Nathan has a lot of stuff. That's great. That's a great thing. What I'm a bit concerned is that it's like the graphic interface. I have technical background, so I prefer Git and code. So that's the only reason that I don't want to use Nathan. But actually, yesterday I discussed with my colleague in my company that, well, I will install it for him probably tomorrow. So yes, we want to use it also. Right tool to the job. Okay, thank you.